Hello, hello friends. Today we are going to see about shape of a liquid drop on solid surface in the chapter mechanical properties of fluid. So see our article shape of liquid drops on solid surface. When a small amount of a liquid is dropped on a plain solid surface, the liquid will either spread on the surface or will form droplets on the surface. Which phenomenon will occur depends upon the surface tension of the liquid and the angle of contact between the liquid and the solid surface. Dear student, we know about the angle of contact. Angle of contact always depend on the liquid and that of the solid. Let suppose theta be the angle of contact for a given solid liquid pair. So there are the three forces. Out of these, consider T1 is the force due to surface tension at the liquid solid interface. Second one, T2 is the force due to surface tension at the air solid interface, and T3 is the force due to surface tension at the air liquid interface. So as the force due to surface tension is tangential to the surface in contact, and the direction of these forces T1, T2 and T3 are tangential. So for equilibrium of the drop, the relation between these forces is given as T2 is equal to T1 plus T3 cos theta. Therefore, cos theta is equal to T2 minus T1 divided by T3. From this equation, we get the following cases. So, see the first case. If T2 is greater than T1 and T2 minus T1 is less than T3, here as the denominator is less than the numerator, so cos theta is positive and the angle of contact becomes acute because the value of cos theta is greater than 0. That's why cos theta is positive. See the following figure. Means here a liquid drop is placed on the solid surface. T1, T2 and T3, these are the tangential forces. There is the formation of acute angle. Now in second case, if T2 is less than T1 and T1 minus T2 is less than T3, here cos theta becomes negative and the angle of contact becomes obtuse, which is shown in the following figure. So here a liquid drop is placed on a solid surface. T1, T2 and T3 are also tangential forces. Here the angle of contact is obtuse, which is clearly shown in that figure. Now see the third case. If T2 minus T1 is equal to T3, So cos theta becomes equal to 1. That means the angle of contact theta nearly equal to 0. And for next condition or next case, if T2 minus T1 is greater than T3 or T2 is greater than T1 plus T3, then cos theta becomes greater than 1, and which is impossible. That means if cos theta is greater than 1, the liquid spreads over the solid surface and the drop will not be formed. Now we are going to see about the next article, factors affecting the angle of contact. The value of angle of contact depends on the following factors, and these factors are the nature, impurity and temperature of the liquid. So first factor means the nature of the liquid and the solid in contact. Second is impurity. Impurities present in the liquid changes the angle of contact. And third one is temperature of the liquid. Any increase in the temperature of a liquid decreases its angle of contact. Here also, for a given solid liquid surface, the angle of contact is constant at a given temperature. Now see the from following table. Angle of contact for pair of liquid solid in contact. See first one. The pair of liquid solid in contact is pure water and clean glass. The angle of contact is 0 degree. Second one, chloroform with clean glass. The angle of contact is 0. Third one, organic liquids with clean glass. Angle of contact is 0. Fourth one, ether with clean glass. Angle of contact is 16 degree. Fifth one, kerosene with clean glass. Angle of contact is 26 degree. Sixth one, water with paraffin. Angle of contact is 107 degree. And seventh one, mercury with clean glass. Angle of contact is 140 degree. Means in first, second and third example, the angle of contact is 0. Here the liquid does not wet the solid. Fourth case, the angle of contact is 16 degree. And fifth case, the angle of contact is 26 degree. These are the acute angle. Here the liquids partially wets the solids. The case 6 and 7, the angle of contacts are 107 and 140 degrees respectively. That means these are the obtuse angle. In this case, the liquids does not wet the solid. So angle of contact is different for different liquid solid pairs. Okay. Now our next article is effect of impurity and temperature on surface tension. First of all, we are going to see about effect of impurity. When a soluble substance such as a common salt, we know about common salt, that is NaCl, means sodium chloride, is dissolved in water, the surface tension of water increases. Second one, when sparingly soluble substance such as phenol or a detergent is mixed without water, surface tension of water decreases. And third one, when insoluble impurity is added into water, surface tension of water decreases. That means when impurity gets added to any liquid, the cohesive force of that liquid decreases, which affects the angle of contact, and hence the shape of meniscus is formed. If mercury gathers dust, then its surface tension is reduced. It does not form spherical droplets unless the dust is completely removed. Now we are going to see about effect of temperature. What is the effect of temperature on surface tension? In most liquids, as the temperature increases, the surface tension decreases. For example, it is suggested that new cotton fabric should be washed in cold water. Why? Means in this case, water does not make good contact with the fabric due to its higher surface tension. The fabric does not lose its color because of this. That's why new clothes are generally washed in cold waters. And hot water is used to remove tough stains on fabric because of its lower surface tension. In this case, of molten copper or molten cadmium, the surface tension increases with increase in its temperature. So we also know about the critical temperature. Critical temperature means the maximum temperature at which the surface tension of liquid becomes zero. Such temperature is called as the critical temperature. Okay. Now we are going to see about the next article, excess pressure across the free surface of liquid. Every molecule on a liquid surface experiences force due to surface tension which are tangential to the liquid surface at rest. The direction of resultant force of surface tension acting on a molecule on the liquid surface. This force also contributes in descending the pressure at the point just below surface of liquid. For this, we consider, let A and B are the two molecules. The molecule A is just above and the molecule B is just below the liquid surface. So the force F be the downward force due to atmospheric pressure, due to which there is formation of three cases: plane liquid surface. So first of all, we are going to see about a plane liquid surface. See in the diagram, on a liquid surface there are the molecule A. Molecule A is just above the liquid surface and that of molecule B is just below the liquid surface. And The tangential forces are shown by Ft. So, for figure shows planar free surface of the liquid. In this case, the resultant force due to surface tension Ft on molecule B is 0. The force Fa itself decides pressure, and the pressure at A and B is the same. That's why it forms a plane surface. Now, second, that is B, convex liquid surface. See the diagram. There is a spherical liquid surface. Here also point A is just above the liquid surface and point B is just below the liquid surface. There are also two forces. Fa is the atmospheric force and that of Ft is the tangential force. So from this figure, surface of liquid in figure is upper convex. In this case, the resultant force due to surface tension Ft on the molecule B is vertically downward and adds up to the downward force Fa. This develops greater pressure at point B, which is inside the meniscus. Hence, the pressure on the concave side, that is inside the liquid, is greater than that on the convex side, that is outside the liquid. Now, third one, that is C, concave liquid surface. See the diagram. Here is the concave surface. Here also two molecules A and B. A is just above the liquid surface and that of molecule B is just below the liquid surface. There is also two forces. Fa is atmospheric pressure, which is downward direction, and that of Ft is the tangential force, which is in upward direction. So surface of liquid in figure is upper concave. In this case, the force due to surface tension Ft on the molecule at B is vertically upwards. The force Fa due to atmospheric pressure acts downwards. Forces Fa and Ft hence acts in opposite direction. Therefore, the net downward force responsible for the pressure at B is less than that of force Fa. This develops a lesser pressure at point B, which is inside the liquid and on a convex side of the meniscus. Hence, the pressure on the concave side, that is inside the liquid. So, this topic is finished. There are some questions related with this topic. First question C. Explain effect of impurities and temperature on surface tension of liquid. Second question is explain the condition for formation of drop. And third question, explain that there is excess pressure on the concave side relative to convex side of a curved liquid surface. Thank you, students.